Just like Core Data is Apple's framework for manipulating data, Core Image is their framework for manipulating images. Now, this is not drawing, or at least not for the most part. Instead, it's image effects. That means things like blurs, or vignettes, or pixelation, or sharpening, or crystallization, and all sorts of other interesting things. If you've ever used Apple's macOS app, Photo Booth, that's basically a core image showcase. And you'll see you can create nearly all, if not all of those effects, straight up with built-in filters. However, Core Image does not integrate very well with SwiftUI. In fact, I'd go so far as to say Core Image integrates well into basically nothing at all, not even UIKit, Apple's older framework. However, there are a few little helpers here and there, and once you're past the initial setup work and understanding, it's worth it. The results are quite brilliant, and you'll learn interesting tools and techniques you can apply to your other projects too. Now first, we're going to write some code to give us a basic image. And I'm going to structure this in a very strange way, but it'll make sense once we bring in Core Image, because we're going to make our image optional, so we can change it later on, and well, you'll see as we go. Anyway, I'm going to say up here, we've got @state private var image is our optional image. That's the one we want to show. Then I'll say below that, there's a VStack with our image inside, and then a question mark there so I can apply resizable and scale to fit. And then for the VStack, I'm going to call on up here, perform load image. A new method down here that will do image equals our image of example. So, like I said, a strange way of structuring it. This thing really could have been right inside here. It's not that intentional. It'll make sense once we bring in Core Image. First though, notice how cool optionals are in SwiftUI. We can just go ahead and use it here. It just works without any further code. If it exists, it'll be drawn. I've added the VStack around it though, because otherwise the image won't always be there, and so there's nowhere to have the onAppear. And so the onAppear wouldn't be triggered for a nil image, so we've got to have that attached to the VStack around it. That's the only reason the VStack's there. Anyway, when this runs, I've added an example image already to my application asset catalog. Of course, you can go ahead and do the same. Press Command-R to build and run. And all being well, we should see our image scaled to fit inside this iPhone 13 Pro. There we go. Now, that was the easy part. The complex part. What is this? What is image? Now, as you've seen before, this thing is a view, which means we can place it inside our SwiftUI layouts and our hierarchy of our views, and we can position it, we can scale it, we can animate it, and so forth. That's all fine. But it also handles loading the image. This example thing here understands find that in the asset catalog, or it can load SF symbols, and it's capable of loading from a handful of other places too. It's a very powerful little loader, this thing. However, ultimately, it is something that gets displayed. That's it, this thing up here. It'd be drawn on the screen somehow, and it's great at that. It's great at displaying stuff, but we can't write its contents to disk. We can't read the image pixels out of here and transform them somehow and whatever. All we can do is apply some basic SwiftUI filters to render them in different kinds of ways. Brightness, contrast, saturation, whatever. They're all there, but I can't get the actual image data. Now, if we want to use Core Image, that means SwiftUI's image view isn't going to cut it. It's a really great endpoint. Render my image now to the screen, but it's not useful for working with pixel data, for actually reading image data here. And so if we want to create images dynamically, which we do with Core Image, which means applying filters to transform it somehow, then perhaps save them to the photo library later on, then SwiftUI's image views are just not up to the job. They can't handle it. Now, cunningly, for historical reasons, Apple gives us 3 other image types to work with on iOS alone. There's more if you count in macOS. And cunningly, brilliantly, we've got to use all 3 if we want to work with Core Image. All 3. And they're going to sound super similar, right? But there is some subtle distinction between them, And it's important to use them correctly if you want to get anything meaningful out of core image. So we have seen already SwiftUI's image. Forget that one, that's over there, SwiftUI land. We're leaving that land and going to UI image. UI image, and the UI means it comes from UIKit, and this is an extremely powerful image type used for the majority of iOS apps before SwiftUI came along. It'll load bitmaps like ping files and JPEGs, it'll load vectors like SVGs and similar, it'll even do image sequences into animation. It is the standard image type for UIKit, and of the three alternatives, it's probably the closest to image, the SwiftUI's image. So that's UI image. Then there's CG image. And the CG, like CG point, CG size, CG rect, that means it comes from core graphics. And this is a simpler data type, which is really just a two-dimensional array of pixels, just some data. UI image adds a lot of functionality on top of CG image. Second one, that's CG image. And the last one is CI image. And CI says it comes from core image. This is core images format. And this is different. This is very, very different indeed. This stores all the information required to produce an image, but doesn't actually turn that into pixels until it's asked to. Apple actually calls CI image a recipe. Like it contains the ideas of images as opposed to the finished pixels, as opposed to the actual finished image. Anyway, there's three other types. So image is SwiftUI, fine. UI image, CG image, and CI image all have to work together to produce our finished result. It's quite complex, but it'll be fine. Honestly, it'll be fine. There is some interoperability between these two types here. We can make a UI image from a CG image and make a CG image from a UI image. They work together quite nicely. We can make a CI image from a UI image and from a CG image that way if you want to. And make a CG from a CI if you want to. And you can actually make SwiftUI's images here, these things, from UI images down here, and I believe also CG images somewhere too. There's so many of these things to work with. They are CG images. There you go. So it can load CG image into here if it wants to. Whew. Okay, so there's three other kinds of images. You need all three, painfully enough, but they're all data. UI image, CG image, and CI image, all image data. We cannot place them in our SwiftUI view hierarchy. We can manipulate them freely. We can present the result in a SwiftUI image when we're ready, but otherwise it's going to be just data. Anyway, the reason you got to know this is because we're going to go ahead and change load image now, so it creates a UI image from our example image. So we have image data. We'll then manipulate that using core image. More specifically, we're going to have to load our image using a new initializer called UI image named, which basically looks like this. UI image named example, and it will load it from the asset catalog, just like our image example right now. A slight difference for historical reasons. UI image named returns an optional UI image, because it might not be there. Whatever. Anyway, it does, annoyingly. We'll then convert that into be a CI image that can go into core image. All right. I know that was lots of talking. It'll make sense now. First things first, get rid of this junk here. Guard let our input image be a UI image named example. If we can't load that for some bizarre reason, bail out. I mean, it's always going to work, but just in case, let's bail out, right? That's our UI image. Core image can't read that. It needs to have that as a CI image. So we'll say now, let our begin image equals a CI image with image of our input image. And that is now a CI image that can go into core image and be manipulated freely. So we're going to add some more code to come down there. So the next step will be to make a core image context and a core image filter. Now, filters are things that do the actual work of transforming image data somehow, like blurring it or twisting it or sharpening it or who knows what. That's all by a filter. Contexts handle converting that data into a CG image. Actually handles all the memory behind the scenes to do the transferring of the image recipe into actual finished images. Both of these come from core image. So we've got to add some imports to the top of our file up here. We've got to add import core image and import core image.ci filter built-ins. Give me all the built-in CI filter types we can monkey around with our image pixels in all sorts of interesting ways. So down here, there's more code to come. We're going to start off making our context and filter. We'll do something real simple to begin with, a sepia tone filter, get a brown tone to our color automatically, like it was taken a long time ago, for example. So we'll say here, let context be a new CI context, and let current filter be a CI filter.sepia tone. A sepia tone filter. And we can now go ahead and customize that filter to change the way it works. Change the recipe. What do you want in your cooking pot of CI filter data? This is a simple filter. It has only two properties. One is called input image, which is the CI image you want to change. That'll be our begin image there. And then intensity. How strong should the sepia effect be, where 0 is the original image and 1 is full sepia tone. So we'll say our current filter has the input image of our begin image and has the intensity of 1. So full on sepia tone like that. Now, so far, this is tedious, but not particularly hard. Here's where that changes. Because at this point, we've got our recipe. We've said, make a context, give me sepia tone with this strength, this image, yada, yada, yada. We're now going to get that out. Convert the output of that into a real image we can show inside SwiftUI. And this is where we're going to lean on all four baffling, all four image types at the same time. Because the easiest thing to do, honestly, is to read the output image from our filter, which will be a CI image. This might fail, so return optional. And again, that'll be a recipe, not the finished thing, it's a recipe. We'll then ask our context we made a minute ago to convert that into a CG image. This might also fail, so again, we'll get an optional. Then convert CG image to a UI image and UI image to a SwiftUI image. Now, you can go direct from a CG image to a SwiftUI image, but it requires extra parameters and just adds extra complexity. It will not work for our final project, so we can't do it here. So, here's the horror in its fullness. Guard let output image be our current filter.output image. Else return. So read the CI image out, just a recipe, remember, from our current filter based on settings we provided. And now we'll say if we can get a CG image from context.createCGImage, and this wants an two parameter version here, the CI image and a rectangle to read from, that one. So read from our output image, and it wants to know how much of it you want. The answer is all of it. In this case, we actually say output image.extent. That is the full size of our recipe. If we can read that, then we'll convert that into be a UI image. So we'll say let UI image be a UI image with CG image, that CG image. And finally, convert that into our SwiftUI image for display on the screen. So image equals our image with a UI image of that UI image, like that. That's the full code. It's a bit old school, but there you go, that's what it is. Go ahead and press Command R now, and all being well, you should see a sepia tone picture of Singapore Airport. There we go, like it was shot a long time ago, despite there being a monorail in the middle and a beautiful fountain there as well. Anyway, sepia tone. And of course, it's adjustable with you can add a slider or whatever you want to change that value from 0 to 1. You might well think, in fact, you probably are thinking, that was a lot of work just to get a fairly simple result. But now we have all the basic components of core image working. It's now relatively easy to jump to another kind of filter. I would say core image can be a little bit creative in the way it handles its filters. It was introduced way back in iOS 5. By that point, Swift was actually well underway in Apple, internally in Apple, but honestly, you really wouldn't know it. For the longest time, core image was the least Swifty part of all of iOS. It was absolutely vicious. Apple has slowly chipped away at it. You're seeing now the improved version of the API. So we'll need both here, modern and old API. First things first though, just to keep you happy for the time being, let's look at some other examples we can do very easily. We could say I want a CI filter with pixelate. And pixelate, we can give this thing, instead of an intensity, a scale. How big we want the pixels in our image to be. Keep in mind, these are applied before the resizability. So we're saying I want 100 pixel sized pixels, 100 width per pixel, but that's in our original image, which then scaled down to fit. So it won't be exactly 100 on the screen, it'll be a lot smaller than that. But anyway, we'll see a lovely pixelated picture, hopefully. There we go. Beautiful. With hardly any work, right? Because all the setup work's done for us, the rest of it isn't changing. We could say I want to have a crystallize filter, and this takes a radius. Let's do 200, so super crystallized. And you'll get a lovely effect like this. There we go, gorgeous. And again, it's completely flexible. Try 100 or try 50 or try 20 to get varying kinds of effect. There we go. It's really, really nice and so little work as well. And you can get more advanced stuff. You can even say I want to have a twirl distortion filter. Now this thing takes a radius, how much to twirl. I'll do 1,000. But it also takes a center point where this twirl should start from. And I'll make this a CG point with the X of our input image size width divided by 2 and Y of our input image size height divided by 2. So the center of our input image. So it'll create a 1,000 point twirl distortion field around the center of our picture, creating that. So there's a lot we can do with core image. Once the setup code's in place, you can create really lovely effects without a great deal of work. And this is all the modern API. But for this project, we're going to kind of mix a little bit of modern and a little bit of old, because the old API allows us to set values freely. Because here, I've said things like, twirl distortion has a radius, has center, has whatever. But if I switch across to be pixelate or crystallize, or we had sepia tone to begin with, for example, that hasn't got radius and that hasn't got center, right? It won't work there anymore. And so we've got to change our code for every kind of filter we want to use. In this project, we'll have lots of filters. So rather than having lots and lots and lots of code, hey doggo. Rather than having lots and lots and lots of code, we are instead going to dynamically query our filters, hey both dogs, to say, hey, what do you support? Come on, come. What do you support? And then provide values just for the ones they support. And in fact, we can actually abuse one value to get all kinds of effects with just one slider, as you'll see. In a slightly different style, though. So we'd say, I want to have a twirl distortion filter with the current begin image. That hasn't changed. But then we can say, give me a value like, say, 1.0 on a slider, for example. And then we can query our, hey, come on, you get one treat. We can query our filter for its input keys, which keys it support for us to work with. We can say, let input keys equals our current filter dot input keys. Okay, one more treat. Come on. Good dog. Oh, you too. Back straight away, are you? Come on. Good girl. All right. No more. That really is it. That really, really, really is it. Read the keys supports. It'll tell us, and we can now say, well, does your input keys contain this particular item, which would be KCI input intensity key. Please use code completion. Do you have a key for intensity? Yes, you do. Brilliant. Let's do current filter dot set value, our amount for the key, that thing. So we inject it in dynamically. If you let me set intensity. And then we can do the same thing for radius or scale, whatever. I'll take them out from here, so it's all done dynamically, basically. We'll say if you support radius key, then set an amount for the radius key. I'm going to multiply that a little bit, because otherwise the radius of 1 isn't very far. Radius of, say, 200 is much more like it. Then we have input scale key and input scale key. And here, again, you want a multiplier, so it's a bit more accurate and interesting. So we'll do times 10. So we're literally saying, For whatever we've just asked for, whatever filter we want, twirl distortion, pixelate, crystallize, sepia tone, read what it actually supports and dynamically read that out and inject the ones it supports. So we'll set intensity and radius if it supports it, and scale if it supports it. But if it doesn't support it, don't even do it. So now we can use, press Command R to get, yes I do see you, hello. Now we'll get our twirl distortion. It's in the corner now because I haven't changed center point. But that's there now. And then I could say pixelate with the same code. The same code. Nothing else is changing now because the rest of it isn't having to change. Let's pixelate all little jaggy edges now, and then we'll do crystallize. All the same code. So no longer adding the values to the type, we're injecting into this dictionary instead, like that. There we go. So it's all now relying on setting these values for keys, which might remind you of the way user defaults works, by the way. In fact, all these things, intensity key, radius key, scale key, and so forth, if you look in the help over here, you will see it's actually a string behind the scenes. It's all stringly typed. So it's even more similar than you might have realized. Anyway, if you are implementing precise core image adjustments, like exactly this filter here with yada, 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 fine. Use a new API, use properties, use all that type safety, all you want to. It's just great. But in this project, the older API becomes much more useful because we can send in any adjustments we want as long as the filter supports it.